Welcome to the tutorial PowerXL DC1 or DB1 frequency inverter optimizing a permanent magnet motor. This tutorial shows how to commission an exemplary permanent magnet motor on a PowerXL DC1 or DB1 frequency inverter. The following technical requirements must be met for this: a DC1 or DB1 variable frequency drive, a DX-CBL PC3M0 serial programming cable or a DX-COM Stick 3 Bluetooth communication stick, and the programming software Drives Connect. This video tutorial is based on the displayed motor datasheet, the set values for the motor parameters, the switching frequency, the selected motor control mode, and the motor values measured during the motor identification run. Detailed explanations of the respective settings are shown in the displayed video. PowerXL DC1 or DB1 frequency inverter commissioning a permanent magnet motor can be found. To check the internal motor model, the drive should be run with load, approximately 50% at approximately 50 to 100% rated speed. At the reached speed, the monitor parameter magnetizing current ID P031 is then to be checked. For this purpose, the following settings are made in the real-time edit mode. The target speed is set to 1000 RPM via fixed frequency 1, P20. The ramp times are each set to 10 seconds. Switch to the Monitor tab and select the box for updating the parameter P031 visible in the real-time edit mode. The monitor parameter P031 magnetizing current should be around 0 in static mode, while the value of IQ should be approximately equal to the displayed motor current. If the value of the magnetizing current ID is seriously greater than 0, the value of P07 motor norm voltage must be corrected and a new identification run must be started for the optimization of the internal motor model. In order to have a good performance during startup and at low speeds, the voltage boost with parameter P11V boost can be used. This acts up to approximately 20% of the rated motor frequency, so in this case example up to approximately 10 Hz per node. Too high values of P11V boost can lead to increased motor current and thus to a higher heating of the motor. If the value of P11 is too high, the set current limit of P36 will be reached, which would lead to a reduction of the output frequency, and thus the DC1 would not be able to accelerate to the desired set point frequency. In extreme cases, an overcurrent shutdown may occur. To check the setting, the acceleration and deceleration times are set to 30 seconds and the stop mode, ramp to stop, is selected. For the observing of the complete frequency range, the fixed frequency 1, P20, is also increased to 1500 RPM. Compared to a standard asynchronous motor with the same rated power, the PM motor has a lower mass moment of inertia. Therefore, the MSC gain, P62, of the internal speed controller can be increased for more dynamic operation. Instead of the default setting of 50%, a value of 150% can be used in this application example without any problems. For performance control, the settings of the data logger are adjusted. Instead of trigger on event, continuous run is now selected. For the second channel, the motor speed is to be displayed, and for the third channel, the speed reference. Is a ramp up to nominal speed without load followed by a stop via ramp. A long acceleration time was deliberately selected here to show the effect of the voltage boost at low speeds. After successful recording, the mouse can be moved over the recording, for example with a right line to view individual operating points in detail. The conclusion of this tutorial is to be a ramp up with 100% constant load. For this, in real-time edit mode, the target speed is set to exemplary 1350 RPM and the acceleration time is set to 3 seconds. The set deceleration time of 30 seconds is kept. Due to the short ramp time, the DC1 enters the overload range of the motor with approximately 18 amps, which is indicated with dots in the display. At the set point speed reached and during the subsequent slow deceleration to just before zero, the DC1 runs with a rated motor current of 14.2 amps. Only shortly before zero does an increased current occur due to the voltage boost. As before, individual operating points, for example start or stop phase, can be viewed in detail after recording. Thank you for your attention.